Hey guys, welcome to your notes on the law of exponents. Here's a little humor for you. It says, so far this seems pretty easy. Guys, just a tidbit of information. We do have a joke board out in the hall, so if you want to participate in that, please bring any math jokes you have. Guys, when we talk about exponents, the whole thing is considered a power. The large number is the base, and the smaller number is the exponent. As we've discussed throughout the first couple of weeks, 5 cubed means that we have 3 factors of 5, which is also written as 5 times 5 times 5. So an example, if we're going from the other way, we have 125 that is equal to 5 cubed. This means that 5 cubed is the exponential form of the number 125. So exponential form is a vocabulary word that you guys need to be aware of. So exponential form is the exponent of a power, and it indicates how many times the base is multiplying by itself. So here we have n times. It's n times because we don't have a set number right now, and it gives us our exponent to be n. Therefore, we have n factors of x. So for this example, 5 cubed equals 5 times 5 times 5. Take a moment, circle which one you think is the exponential form. The second rule we have, this one's really important, guys. If we are multiplying powers with the same base, so the only way that we can multiply these powers if they have the same base, we keep the base and add the exponent. So here is an example. You want to write this down in your notes. If we have x raised to the m power times x raised to the n power, that is going to be equal to x raised to the m plus n. Guys, this is a really important rule. So, for example here, we have our silly guy again. If we have 2 raised to the 6th power times 2 raised to the 3rd power, the bases are the same. Therefore, we can go ahead and add the exponent. So we'll get 2 raised to the 6 plus 3. Continuing on, 6 plus 3 is 9. So we have 2 raised to the 9th power. Therefore, we have just simplified our multiplying powers, but we have not evaluated the expression. So we want to go ahead and work out 2 raised to the 9th power. To do that, we're going to do 2 times 2, 9 times, and it comes out to be 512. So our little friend here says, I get it. When you multiply powers, you add the exponents. Multiplying powers means you add the exponents. The third rule we have is dividing powers. So when you are dividing the powers with the same base, you want to keep the base and subtract the exponents. Here you go with the general rule, x raised to the m divided by x raised to the n is equal to x raised to the m divided by x raised to the n. Those are just 2 different ways to write it. To solve this, we actually subtract the 2 values. So for example, we have 2 raised to the 6 divided by 2 raised to the 2. This is equal to 2 raised to the 6 minus 2, subtracting when we're dividing, which is equal to 2 raised to the 4. And if we evaluate that, we get 16. Here's our little friend. He says, I get it. When you divide powers, you subtract the exponents. This is something you would like to write down, guys. Dividing powers is an important rule when we're talking about exponents. So reminder, if you need to go back and pause for the rules, you can do that. Pause and write down as you please. But take a moment to try these examples. So we're multiplying 3 squared times 3 squared. When we multiply exponents, we blank. Oh, great. You said add. Good to know. So go ahead, stop the video, pause, write these down, work these out. Guys, these are awesome problems for if you are going to need to go back and review. You can always come watch these. Over here on the other side we have division, so these are all for you to work out. You can choose a few or you can do them all, it's up to you. But if you're going to do some, you need to pause it now because I'm going to move on. Here we have some solutions, guys. So if you start with the first one, 3 squared times 3 squared is the same as 3 raised to the second power plus the second power, which is also 3 raised to the fourth. If we evaluate, that is 81. Take a moment, compare these with your answers if you guys did it. We are going to go ahead and go on to the next couple of problems, guys. This is just for you to check yourself. I'm not running through each of these because you can pause or rewind, whatever you need to do. Alright, so another rule, when we have a power of a power, that means if you are raising a power to an exponent, you must multiply the exponent. So I don't know about you guys, but that's super confusing in words, and I need an example. So the general rule here in the box, which you want to write down, if we have x raised to the m, and then it is also raised to the n, that is equal to the same thing as x raised to the m times n. So we're going to multiply those. Let's get our little helper out and see what he's got here. So he's got 5 raised to the third power, which is also raised to the second power. So this is equal to 5 raised to the 3 times 2. So here we have a little bit of a mistake. I hope you guys can spot it. What is 3 times 2? 6. Good work. So this should be 5 raised to the 6th power, not 5 raised to the 5th power. Here's his little helpful hint for you. When you take a power to a power, you want to multiply the exponents. Totally. 5. The product law of exponents. So if the product of the bases is powered by the same exponent, then the result is the multiplication of the individual factors of the product, each powered by a given exponent. Remember, guys, you don't have to write all this down. What I would write down is what's in the box here. So what we have now is we have 2 bases. So we have x and y raised to the nth power, and all we need to do is break that apart so we get x raised to the nth power and y raised to the nth power. Here we have ab raised to the second power. Same thing, split it up. That power is representative to both bases, so that gives us a squared and b squared. So when I take the power of a product, I apply the exponent to all factors of the product. Exactly. Six is the quotient law of exponents. If the quotient of the bases is powered by the same exponent, then the result is both the numerator and the denominator will each be powered by the given exponent. Gibberish again, guys, but remember the most important part is this right here, the examples. So here it's division. We have x divided by y raised to the nth power, and that is the same thing as x raised to the nth power divided by y raised to the nth power. So here's another example. If we have 2 divided by 3 raised to the 4th power, that is the same as 2 raised to the 4th power divided by 3 raised to the 4th power. If we evaluate that, that is 16 divided by 81. So when I take a power of a quotient, I apply the exponent to all parts of the quotient. Perfect. So here's some examples again, guys. I want you to pause if you would like to work through these. If you do not, if you feel comfortable, you're more than welcome to go on. But a reminder, when we take the test, if you have to retest, these are perfect places for you to come back and see how do you actually solve these problems. So the first one, we have 3 squared raised to the 5th power. So this is a power raised to a power. I'm going to think about how that works out. I'm going to pause, give you guys just a little bit of time to pause the video yourself and write down the problems. Okay, so now you're ready to check yourself, and the solutions are as follows. Remember, guys, I'm not going to go through them individually. We've already went through the rules. If you need help going through these, please feel free to come see me or turn on your light, and I will be there as soon as possible. Please pause the video now to record these answers and see if they match yours. Here's the remainder of the solutions, guys. If you want to pause as well to write these down, I would suggest to do that. Guys, I think this is the last law we're going to do. If the base is powered by a negative exponent, then the base becomes the reciprocal with a positive exponent. Reciprocal is a really important word for us to know. If you guys do not know that one yet, please know it's going to be in our vocabulary a lot. A reciprocal is when we have basically the opposite. So here we have x raised to the negative m. The reciprocal of that is going to be 1 over x to the positive m. Here's an example of 5 to the negative 3 is equal to 1 over 5 to the positive 3, which we can evaluate to be 1 over 125. Next, if we have a negative exponent in the denominator, that means in the bottom, it is completely okay to evaluate that as well. So all we do is we flip it, the reciprocal, flip and take the positive. So we're going to flip it up to be 3 squared, and we evaluate that to be 9. So when I have a negative exponent and I switch the base to the reciprocal with the positive exponent, if the base with the next negative exponent is in the denominator, it moves to the numerator and loses its negative sign. Sorry guys, I thought the last one was the last, but it's not. Here we have the zero law of exponents. So anytime you have a base powered by the zero exponent, it will equal 0. This is one of the easiest ones to remember. Anytime it is raised to 0, it equals 1. Sorry, I said that backwards. So 5 raised to 0 equals 1. A raised to 0 equals 1. 5 times a raised to 0 equals 1. 0 factors of a base equal 1. Every power has a coefficient of 1. Here's your last example problems. The 0 ones would be my favorite, so I'd do those first. But go ahead, pause the video, take some time, write these down, come back for the solutions. Oh hey, you're back. Awesome. Here's your solutions. Same goes, guys. Take a moment to pause the video. Oh, sorry, I went too fast. Pause right here, check yourself. Make sure your work also matches the problems. And our final solutions. So guys, I know this is a lot of information, but it's all really important for us. So anytime you need to go back, please go back and rewatch this video. Make sure you have notes to go with it. Have an awesome day.